Alright, this lecture is about working with rational equations. It's section 12.5 in your book, and that is working with rational equations. Okay, we're going to emphasize this word equations. A ratio is comparing two numbers using division. So when you see the word ratio in here, it's comparing two expressions. So it could be like a 2 over x plus a 1/3. That is an expression. It is not an equation. You could have something like x squared plus 1 over x squared minus 25 divided by 3x over x plus 5. These are expressions. You cannot solve them, but you can simplify. So without having directions here, whenever you have an expression, what you do automatically is simplify. So you factor, you reduce, whatever is common. In the next, this section, the next topic here is rational equation. So that has an equal sign, and if it has an equal sign, that is something that you can solve. So make sure when there's an equal sign you solve it. When there's not an equal sign you can't solve it. So an example of a rational equation would be 2x plus 4 over x squared plus 9x plus 18 equals 6 over x plus 3. These are rational equations. Okay, so let's go ahead and look at our steps for solving a rational equation. Step number 1 is you're going to factor the denominator. Factor the denominator. Step number 2, you're going to find the least common denominator. Remember, that means least common denominator means all factors to the highest power. All factors to the highest power. Third, you're going to clear fractions. And when you're clearing fractions, you're going to multiply the whole equation by the least common denominator. Multiply whole equation by that least common denominator that you found. And the fourth step is solve equation and check solution. Solve equation and check solution. The big deal in this set of problems when you have rational equations is this step right here. Big, 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 big. 5 stars. Okay, so that is the difference between section 12.6 and 12.7. You don't like this equation number 1, 2, 3, or whichever. It's because you have fractions. So you're going to clear the fraction. You're going to determine, well, first step is to factor your denominator, and in number 1 there's nothing to factor. So we're moving on to step number 2. The least common denominator. If you look at all of your denominators, the smallest expression that they can multiply into is 3x. So you're going to multiply, we are now on step number 3, you're going to multiply the whole equation by the least common denominator. That means you're going to clear fractions. If I distribute this to the first term, you have a 2 over x times a 3x over 1, plus distribute it to the second term, 1/3 times 3x over 1. Distribute it to the other side, 4 over x times 3x over 1. Now in doing that, these x's will cancel and you'll have a 6. Second term, the 3's will cancel and you'll just have an x. Third term, or the other side of your equation, the x's cancel and you have a 12. That's a nice equation. To get x alone, subtract your 6 and x equals 6. Your check is, back at the original, is 2 over 6 plus 1/3 equal to 4 over 6. Well, this is going to be, whoopsie, that's going to be reduced to a 1/3 plus a 1/3 equals, this reduces to a 2/3. So yes, 2/3 equals 2/3, and that is a check. And so I circle my answer. Second problem, same thing, factor your denominators, but there's nothing to factor. That's your first step. You'll get to some on the back side. And then find the least common denominator. The least common denominator is the same thing as you just had. It's 3x over 1. But now I'm not going to write it out like I did in the first one in this step. I'm going to just distribute. I'm going to multiply the whole equation by the least common denominator, one step at a time. I'm distributing here. When I multiply these two, I'm going to get a 12x over x. That will reduce down to just a 12. When I distribute to the second term, I put a plus. I will get a 6x over 3, and the 6 and the 3 reduce to a 2x. Other side, when I distribute, I get an 18x over x. That reduces to an 18. Nice equation. I'm going to subtract the 12. You get 2x equals 6. Divide by 2, x equals 3. You're checking it into the original. Does 4/3 plus 2/3 equal 6/3? This is added together. You get 6/3 equals 6/3, and that's a check. So I circle my answer. Next one, you have factored denominators. I don't need to factor them, so step number 1 is done. The least common denominator is the quantity of 3 times y plus 2, all over 1. Now if I distribute the least common denominator, I'm going to multiply the least common denominator to each term on each side of the equation. If I distribute it to the first one, the x plus 2's cancel. And then I'm only left with this 15. If I distribute it to the second one, the 3's cancel. And I'm left with y times the quantity y plus 2. So it's the same in this case as if you were to cross multiply. If you have two equations equal to each other, you can cross multiply, you'll get the 15, and it equals y times the quantity y plus 2. So this problem can actually be done either way. Keep going. 15 equals y squared plus 2y. It's a quadratic, so set it equal to 0. You have a minus 15, and then I'm going to put 0 on the other side. Factor y plus y minus, it's going to be a plus 5 minus 3, that equals 0. Y will equal a negative 5 and a positive 3. So when you check, you're checking them both. First check, you have 5. I'm going to check this negative 5x in there. So you put 5. If you put a negative 5x for your y, you're going to get, a negative 5 in for your y. You're going to get a 3 in the denominator, a negative 3. Okay, if I put the negative 5 in the next fraction, it has to go in the numerator, it's a negative 5 over 3. So that works, they equal each other. Negative 5 works. Check 3, I have 5 over, putting 3 in for y, it's 3 plus 2, which is 5. If I put the 3 in the numerator of the next fraction, it's 3 over 3, and 1 equals 1 when you reduce those, so the 3 is also an answer. So both check, and so you circle both. Okay, I'm going to stop here and record the back of your notes on another segment of this, another video. Alright, back soon.